Okay, looking at lesson 5, we're going to apply some properties of logarithms. And this will help us to rewrite the expressions and kind of be able to simplify and solve. So some of my key properties, if we look at, we have the product property, which again is when we say we were to multiply m and n together, we could also split them apart. So we could have log base b of m plus log base b of n, and that would be the same thing. Very similar, we have the quotient property, except the quotient property, instead of adding, we are going to subtract. So we will take our log base b of m divided by n, and then say, okay, that actually equals log base b of m minus log base b of n. And finally, we have the power property, which if you look right here, this is log base b of m raised to the nth power. What we end up doing is we take that n value and we put it out front. We take it and we move it in front. So these are 3 properties that, again, as long as b does not equal 1, these properties will always hold true. So we'll do an example of each. We're going to use log base 4 of 3/7 and let's see here, log, so this is going to approximately equal 0.792, and log base 4 of 7 is approximately 1.404. So if I take a look, I'm going to say, all right, how do I figure out, because we can't just type this into our calculator. Our calculator doesn't have the feature log base 4 of 3/7 to figure that out. What we would say is we could say, well, we have log base 4 of 3. Oops, this should just be, yeah. So we give you each individual one. I apologize. There we go. Minus log base 4 of 7. So again, now I could just do direct substitution to get an answer of negative 0.612. We could take log base 4 of 21, and we could rewrite that as log base 4 of 3 times 7. So I could say, well, I have log base 4 of 3 plus log base 4 of 7, which when I plug in my estimations, I get 0.792 plus 1.404, which is going to equal 2.196. And then our last property is the power property. Let's say that we have log base 4 of 49, and that's going to equal log base 4 of 7 squared. So I would say, again, what do I have to do to that 2? I got to bring that 2 out in front. 2 log base 4 of 7, and we know that log base 4 of 7 is 1.404. So if I multiply that by 2, I get about 2.208 or 808. So real quick, 3 different examples going through the 3 different properties. I used what I knew these things, to then manipulate and substitute into the problem. We can also expand a logarithmic expression. So if I said expand log base 6 of 5x to the third over y, I have log base 6 5x to the third over y. That's going to equal, so now I'm going to use the quotient property. So I'm going to split up my top number and my denominator. So I'm going to say log base 6 of 5x to the third minus log base 6 of y equals log base 6 of 5. So now I'm going to split up. Now what I'm splitting up is I'm splitting up 5 and x to the third. So I'm going to say log base 6 of 5 plus log base 6 of x to the third minus log base 6 of y. And now my final thing, so I'm using all three properties here. I've got this that needs to move out front. So my final expansion is going to be 3 log base 6 of 5 plus 3 log base 6 of x minus log base 6 of y. So this is as far as I can go. Again, we used step 1, we used the quotient. Step 2, we used the product. Well, yes. And then step 3 was the power property. All right, one more example here before we shift ideas. Which of the following is equivalent to log base 9? So let's find something that's equivalent to log. Again, if it doesn't have a base, it's base 10. So log base 10 of 9 plus 3 log 2 minus log to the third. First thing I'm going to look at is I'm going to do the opposite. So out here I expanded. Now I'm going to kind of reduce it. So I say that, hey, I've got this. I'm going to do that power property, but in reverse, move it up. And now I'm going to combine these two and use the the product property and say, all right, I've got the same base. So 9 times 2 to the third minus log of 3. And now I'm going to use the quotient property to say, log 9 times 2 to the third. And then that's going to be all over 3. And so if I think about that, 9 times 2 to the third divided by 3 is just going to give me log of 24. So I took this long expression here, and was able to simplify it to log of 24. Okay, so kind of our last idea in this chapter, or this lesson, is the change of base formula. So if I look at this, all right, if A, B, and C are positive numbers with B not equaling 1 and C not equaling 1, then we can use this property. Where you notice A goes here, C goes down here, and B is now the same base. And then notice the couple special cases down here. So let's do an example. If we want to use a common log, so again, a common log is like base 10. So common log is a log base 10. And we want to use our common log for the function log base 3 of 8. We would say, because we like everything to be like base 10, so log base 10 of 8 divided by log base 10 of 3. Again, you don't technically need to write this, the base 10 part. We assume if there's nothing written, it's base 10. And so if I were to, again, use my calculator, I would say, all right, what's log of 8? Let's see here. Mr. Orson got a new laptop and doesn't know where his Desmos app is. Okay, well, if you use your calculator, you will find that log base 8 is about 1.893, and log base, that's not correct. It's 0.9031, and log base 3, or log base 10 of 3 is 0.4771, and so when you divide those two numbers, you get approximately 1.893. If we wanted to simplify this using natural logs, so again, remember a natural log is like ln, the natural log of 8. So we would say ln of 8 over ln of 3 is going to give me approximately 2.0794 all over 1.0986. Which if you take these two numbers and divide them, you get 1.893. 1.893. So if you are stuck with it, we like having natural logs or common logs. So if you're stuck with something that you're not sure how to simplify, you can use this change of base formula to get it into base 10 or get it into the natural logs. And then you can use your tools, aka your calculator, to help you solve that. All right, I'm going to take a picture, one last example using logs in real life here. So let's take a look at this. I gotta crop it. There we go. Graphing sound. This is like, when are you going to use logs in real life? For a sound with intensity I in, watts per square meter, the loudness of the sound in decibels is given by the function. Okay, so we've got this nice function here where I sub 0 is the intensity of a barely audible sound, about 10 to the negative 12 watts per square meter. An artist in a recording studio turns up the volume of a track so that the sound's intensity doubles. By how many decimals does the loudness increase? So to figure out our loudness increase, we're going to take our new function, which we're going to say is, if it doubles, that means we have to take this function and multiply it by 2. So I'm going to say 2i rather than 1i. And then I'm going to subtract that from what I originally had. So I'm going to double it, and then I'm going to subtract it. And that's going to give me my new answer. So if I look at my function that I have right here, I'm going to say, all right, this is 10 log. Every time I see an I, I'm going to say that it's 2i, and then this is still my very initial term, I sub 0, minus, I forgot the 10, minus 10 log, again, I over I sub 0. So again, really the only difference is this term right here. Now we can use parentheses. Okay, so I'm going to factor out this 10 from both sides. I'm going to factor this 10 out, and I'm going to say 10 log 2i minus, or over I sub 0, minus log I over I sub 0. And now I can use my product property to figure out my quotient property. I'm going to say, first of all, this is 2 times I. So I'm going to split this up. I'm going to say log of 2 plus log of I over I sub 0 minus log of I over I sub 0, which hopefully, again, why do we kind of do this stuff? So that we figure out right here, I have the exact same thing subtracting by each other, which is going to cancel out. So we are just left with 10 log 2 which we can plug into our calculator because it's a base of 10, and we get about 3.101. So the loudness increases by about 3 decibels. So in this situation, the artist increased by doubling the volume of a track. So the sound's intensity doubles, it increased by 3 decibels.